And I still need you to go into this. Just go ahead and put that in your pocket or hang it somewhere.
Okay, can you hear me? All right, it's been fun and learning a lot of different insights. Tonight, I wasn't sure what I was going to talk on. Bill, he pinged me and he said, do you have anything you want to share? And I was actually not even going to be here tonight. I had back surgery this morning and I wasn't sure if I was going to make it, but I was like, well, after he asked me and I sort of said, no, I don't think I can make it. Then something popped in my head, and what you're about to experience is a quick thought, and but you're getting your money's worth. So, okay, so quality counts. When I spoke here last year on domain-driven design and designing software, it was kind of an odd duck because a lot of people here are quality people in the software development lifecycle. You're checking things after it's already been developed. And my world is trying to figure out what you're even supposed to develop. And I clicked the button. Oh, wait, hold on one second. Highlight it. So let's see if that works next time. Okay, so as we're thinking about designing or testing software, do we actually know how much we waste on poor quality software? Are we measuring? We're aiming towards high quality software, but are we measuring poor quality software? And so we're going to talk a little bit about that. Technical debt is a piece of poor quality software, but we're going to get into that a little bit more. I just want to give a little background. Ward Cunningham, who was actually in this Quality Jam last year and spoke on the spaces between modules, he gave us this term back in 1992 at an UPSLA conference, technical debt. And since then, it's been defined many times by many people in many different ways. So we're going to take a look at that tonight. Before we get there, I wanted to kind of answer this question a little bit. What does it cost us to have poor quality software? Adam Thornhill, he is the inventor of CodeScene. If you've never heard of it, it measures basically the quality of a code base. He wrote the book called Your Code as a Crime Scene. He was a forensic scientist who turned software quality professional. He's out of Europe and he is phenomenal. He's working with AI and he's helping the world learn what the appropriate use of AI can be the more he tests it. But he has a white paper out there, and that's that long calculate business costs and technical debt.pdf with dashes in between it. Has a few of these quotes. The average organization wastes 23 to 42% of their development time due to technical debt. Technical debt is often mistaken for bad code in general. This is a dangerous fallacy, and we'll talk a little bit about that. Based on data, many organizations pay for 100 developers, but are only getting the output equivalent of 75. What other industry could get away with this? Hire 100 auto manufacturer workers and only 75% of them produce anything of value. Well, we won't go there. That's a little running joke between us right now. So that's an interesting dilemma. There's money being left on the table. There's profitability to be had if we solve this problem, if we're looking at poor quality. Okay, so let's dig into that. The AI definition, because I had to do that, right? We're in the world of AI, so I needed to give you what AI told me the definition of technical debt was, and rework. These two very similar words. Technical debt is the extra work required to fix issues caused by choosing a quick solution over a more efficient one in software development. It's pretty close. Rework. Software rework is the process of correcting or modifying software after it's been developed. I would say deployed. So these are good definitions. I would refine them. So I did. Here they are. My definition: technical debt, the cost of software design, development, and deployment intentionally delayed until profits can pay for the added benefits of a known refinement on the design. Intentionally delayed. That's what technical debt is kind of supposed to mean. And Bob Martin has written about that. And rework is the code we have to touch and or fix after the solution was delivered. So some problems with code are like financial debt. It's okay to borrow against the future as long as you pay it off. That's what Ward Cunningham said. That's a quote that's on the Agile Alliance. So what we want to do is we want to clarify the cost and activities of paying off technical debt is all rework, but all rework, however, not all rework pays off intentional technical debt. Much rework is due to accidental complexity rather than intentional design trade-offs. We're making software, we deploy it, we made mistakes. They were not intentional. These are the bugs we're talking about, right? So there's a big difference between deciding, hey, we're going to do this on-prem, and then when we're making money, we're going to go in the cloud, and that the cost of transitioning from on-prem to the cloud is going to be approximately this amount because we know that we have to do all of these different things to get from on-prem to in the cloud, and that's an intentional trade-off to create profit. That's one way to look at technical debt, and I think that's a very valid way. And there are thousands of things we can do to get to market faster because we don't want to pay the cost of more refinement because we want to start making money sooner. And that is valid. What happens is we do that too often and the cruft builds. And the intentional tech debt builds on each other, and then we start making bugs. And then it becomes a spiral process downward where we can no longer fix the software and we can't add new features. And this is where legacy then becomes, hey, we need to rewrite it. And the cycle starts all over again. But if you manage technical debt and pay it off in good time, you may not have to retire your systems. It can be adaptive over time. So, main point, intentional tech debt. Measure the planned rework against the cost of not completing the design when adding new features. So when you think about it, we've got these intentional delays. We don't want to put this stuff in there, but we want to add these other features. Is it going to cost you more to add the other features without the foundational improvements you delayed than it would if you were to do the foundational improvements and then put those features in? And I think we kind of need to step back sometimes when we're delaying that tech debt, that intentional, we keep delaying it. Well, how is that impacting software development? And it may be that it will cost less to pay the debt down and then add the features than to try to add features brute force on top of your system. So that money you can save in development. And an unintentional mistakes are inevitable. Repeating them is not inevitable. If we were to measure our mistakes, it's okay to make a mistake, but in a really healthy environment, we should be able to detect a mistake pretty quickly and then come up with solutions to prevent that in the future so we can reduce rework there. So to Moss's point, I wanted to have this conversation on communication. What are we communicating about tech debt? And how can we refine that abstract idea into something specific that we can measure and then improve the cost of development over time by reducing mistakes and by paying off tech debt in a more appropriate manner?
Oh,
So here's my pro tip. This is the end. Center your software designs around the decisions your software will make, not the data it will create. Most people design software with the database first and the UI next and try to jam the logic in the middle. And this is ripe for creating bugs in your software. If you design your software systems by clumping the decisions appropriately first, and then applying the UI and the data as appropriate to support that behavior, the context of the software doesn't change very often, and the bugs will be few. So this is a way to create a lot fewer side effects in your software. If you flip the mentality, we're no longer building applications in this world. We're building systems with applications on top. Application development from the 90s, database, UI, logic. That was valid. Today, systems, behavior, supporting data, and user interfaces. Behavior first. That gives you your context, and that will reduce rework. And that is my talk.
Thank you, Jim. Who's next, Moss?
Scott.
Scott, you're up.